In this video, I'm going to go through some of the pre-calculus review problems on page number 5 in the notes. So here are several problems given that I think are good review problems for the pre-calculus, college algebra, and trigonometry you need to know for calculus. I'm not going to go through all of these, but I do encourage you to practice all of these in your free time when you have a chance. I'm going to only go through some of these problems. There's, I think, 42 problems total. Okay, I'm not going to do all 42. I'm just going to pick a few problems from here and go through those. Okay, the first problem I'm doing is number 1, part A. All it says is simplify. So I have a rational expression that I'm supposed to simplify. First thing, I'm going to go ahead and factor the top. I can pull out an x from the numerator and also factor the denominator. Looks like it's a quadratic equation, ax squared plus bx plus c type, and my a is 1, so these are easier to factor. You're looking for two numbers, they multiply to give you positive 12, they add up to give you negative 7. Now on the top, I still have difference of squares, x squared minus 9 is difference of squares. I can go ahead and factor it more. And on the bottom, I have x minus 3, x minus 4. We can cancel the x minus 3 and x minus 3. And that's it. Nothing else can be canceled between top and bottom. Looks like this is the fraction in the simplest form. So I can leave it as this. If you want, you can go ahead and multiply the x, distribute the x in the numerator if you prefer, but you don't have to. Next, I have number 1, part C. Number 1, part C, we have 1 over x minus 1 over 5. This, on the bottom, I have common denominator. This is a complex fraction because we have fraction in the numerator and fraction in the denominator. So the LCD for the top fraction is 5x, and I need to multiply first fraction top and bottom with the 5, second fraction top and bottom with an x. And LCD for the denominator is 25x squared. First fraction gets multiplied with 25, the second one gets multiplied with x squared. So far I'm treating the top and bottom fractions separately. I'm not merging them, not combining them. Now, instead of using this division line in the middle, I'm going to write these with a division symbol. So I'm doing 5 minus x over 5x divided by 25 minus x squared over 25x squared. I am left with 5 minus x over 5x times 25x squared over 25 minus x squared. Let's go ahead and factor and cancel whatever we can cancel. 5 minus x over 5x times 25x squared over 5 minus x times 5 plus x. This is difference of squares. So 5 minus x and 5 minus x is gone. And 5 times 5 is 25. X and x is gone. And I'm left with 5x divided by 5 plus x. Okay, and that's my simplified fraction. There's nothing else that we can do about it. Next one is rationalize. So I'm supposed to rationalize that fraction here. So get my little more space. Whenever we need to rationalize the denominator, you have to read carefully. Sometimes you are asked to rationalize the denominator. Sometimes you're asked to rationalize the numerator. In this case, it's the denominator because that's got radicals in it. So you multiply top and bottom with the conjugate. Okay. Now on the top, I'm going to distribute that 2 into the whole parentheses. And the bottom, so this becomes 2 root 3 minus 2 root 2. The bottom would be a plus b, a minus b, which is a squared minus b squared, which is just 1. So only thing I'll be left with is 2 root 3 minus 2 root 2. The denominator is just 1. There's no need to write that denominator. The next problem is exponents. Simplifying the exponents. This is number 3, part F. So a to the power 2/3 divided by b to the power 1/2, everything raised to the second power. This power is going to multiply with both the exponents there. So a to the power 2/3 times 2 becomes 4/3. B to the power 1/2 times 2 becomes just 1. And then the second parentheses, I have b to the power 2/3 divided by a to the power 1/2. Now, because I have the same bases on top and bottom, I can subtract the exponents. 4/3 minus 1/2, b to the power 2/3 minus 1. So when I simplify, this turns out to be a to the power 5/6, b to the power negative 1/3 when we get the common denominator there, which turns out to be a to the power 5/6 divided by b to the power 1/3. And that's all for this problem. There's no more, nothing else we can do or combine any more exponents. Both the variables are different, so we cannot subtract the exponents anymore. We don't have the same variables. Next problem I'm going to look at is number 4, part A. It says solve this equation. Okay, it's an exponential equation because the variable is in the exponent. And how can you solve an exponential equation? My first try is to go ahead and write both sides with the same base if possible. It's not always possible, but in this case it is possible, so I'm going to take advantage of it. 5 to the power x plus 1 equals 5 squared. Now, exponential functions are one-to-one functions. That means if two outputs are equal, the two inputs must be also equal. Okay, we can go ahead and subtract 1 from both sides. X equals 1 is my answer. And that's all for this problem. Number 6, part C I'm doing, and it says simplify. So all I have to do is, it looks like I have two separate logs and I'm trying to condense these logs. First thing, my coefficients are going to become the exponents. Okay, so I can write it as log to the base 10 square root of x to the second power plus log to the base 10 x to the power 1/3 to the third power. Now, you know the square root and square are opposite of each other. They're going to cancel each other. So I'm left with log to the base 10 of x plus log to the base 10 of same thing. 1/3 times 3 is just 1. Now I have two separate logs. I can go ahead and use the product property of logs. Logs have three special properties. If you recall, log, I'm just using the base 10 to keep things easy. Log x plus log y is same thing as log x times y. Log x minus log y is same thing as log of x over y. And a log x can be written as log x to the power a. Coefficient can be written as an exponent. Okay, a log x. Yep. All right, so here we are. We can write it as x squared. Now, if you really want, we can go ahead and bring the 2 in the front, and we can say this is 2 times log to the base 10 of x. When you have base 10, you don't really need to write it. You can ignore the base 10 there. Next problem we're going to do is number 7, part A. It says solve for A. So I have this expression and I'm trying to isolate the A in it. First of all, there's multiple ways of going about it. I'm going to move the y over b and z over c to the other side. Now I'm only going to work on the right hand side for a bit. I'm going to write it as one single fraction on the right hand side with the common denominator. 1 has 1 underneath. So my common denominator looks like would be b times c. The first fraction needs to multiply with b and c. The second fraction needs to multiply with c only. The third fraction needs to multiply with b. So I'm going to have to bc minus yc minus bz divided by bc. So x over a equals bc minus yc minus bz divided by bc. Okay, I'm almost there. I need to isolate the a here. So I'm going to go ahead and write the reciprocal of both fractions because we can do that. If two fractions are equal, the reciprocals are also equal. Now to isolate my a, all I have to do is multiply both sides with the x. So I'm going to multiply left side with an x and the right side with an x. This is going to give me a equals xbc divided by bc minus yc minus bc. Okay, and that's what a is equal to. We isolated our a. Next, we have number 7, part C. We want to solve for r. That means we want to isolate the r over here. As you can clearly see, it's not really easy or possible to isolate the r because we do have an r square involved. If r square is involved, that means I'm dealing with a quadratic equation and I have to bring everything to one side and either factor the quadratic or use quadratic formula. So this is a quadratic in r. We have r square, r, and then no r term. Now quadratic formula, if you remember, x equals negative b plus minus square root b square minus 4ac divided by 2a. That's what I'm going to do now. R is equal to minus b, which is negative 2 pi h, plus minus square root of b squared, which is 2 pi h squared, minus 4 times a is 2 pi, c is negative a, divided by 2 times a. Okay, now from here, go ahead and simplify. I'm not going to bother to simplify, but you guys can go ahead and give it a try and simplify this fraction. Okay. If anything can be pulled out from the square root, do that and just simplify there. Number 9, part B, we are supposed to factor this equation. Well, there's 4 terms. For factoring, whenever you have 4 terms, we do try grouping. In this case, grouping is not going to work because I can see if I pull out a 4x squared from the first 2 parentheses or first 2 terms, my inside parentheses would be not the same if I pull out 25 from the last 2 terms. So grouping is not going to work here. My next goal is to start thinking about the rational zero theorem. What are the zeros for this polynomial? What are the factors of 50 and what are the factors of 4? And that can give us some idea. If you recall rational zero theorem, the factors of 50 are 1, 2, 5, 10, 25, 50. Factors of 4 are 1, 2, and 4. So if this polynomial has any real zeros, they are going to be of the form. So this is my p and this is my q plus minus p over q form. Well, the q does not need to be that long. Plus minus p over q form. Okay. So I'm going to try. I already know 1 is not a 0 over here. I just did a mental plug-in really quick, and I can see 1 or negative 1 are not zeros. My next goal is to try a 2 and see if 2 is a 0. So I'm going to try the 2, synthetic division with the 2. And I have 4, negative 8, negative 25, and 50. Make sure there's no missing terms. If there's a missing term, you want to add a 0 there. So 4 comes down as it is. 2 times 4 is 8. Negative 8 plus 8 is 0. 0 times 2 is 0. There's negative 25. There's negative 50, and I have a 0. So 2 is a 0. If 2 is a 0, that means x minus 2 is a factor. 2 is a 0, x minus 2 is a factor of this polynomial. Okay. And I also have the reduced polynomial over here. This was a cubic. Now I have a second degree, which would be 4x squared plus 0x. I don't need to write that. And 25 minus 25 without an x. Reduced polynomial 1 degree lower than what we started with. Now looks like this can be factored more. We have x minus 2. And then this would be 2x plus 5 and 2x minus 5. And that's the end of it because we were being asked to factor it, not solve it. And it's not an equation. There's no 0 on the other side. So that's the end of the problem. We would stop over here. Next one is actually a solve. So we're going to solve this equation. Again, it's a cubic equation. How do I solve a cubic equation? Let's see. how do you factor the sum of cubes? If you recall, a cube plus b cube is a plus b, and then a squared plus ab plus b squared. Sum of cubes formula. Okay. Sum and difference of cubes, we have seen these before. Actually, this is going to be a negative here. It's SOAP formula, if you remember, same sign, opposite, always positive. Okay, so I'm going to write these two terms as perfect cubes. 2x to the third power plus 3 to the third power equal to 0. Here I am, 2x plus 3. And then a squared would be 4x squared minus 3 times 2 is 6x plus 9 equal to 0. Okay, now I need to plug each factor equal to 0. When I plug 2x plus 3 equal to 0, this is going to give me one of the solutions, which is negative 3 over 2. I also need to plug 4x squared minus 6x plus 9 equal to 0. And it's not factorable, I know that, so I'm going to go ahead and use quadratic formula again, which is negative b plus minus square root of b squared minus 4 times a times c, 4 times 9 times 4 divided by 2 times 4, which is 8. And I can see I'm going to have imaginary solutions here because I'm going to have a negative inside the square root. I'll let you finish that portion, and I'm not going to finish it up from here, but I already see I'm going to have an I in the square root. I coming out of the square root because there's a negative in the square root. Next problem is a trig equation, and it's asking me to solve this equation. X lies between 0 to 2 pi. Okay, so I got x squared cos square x minus sine square x equal to sine x. Let's see, what can we do over here? Okay, I'm going to try to change this into sine, because then I will have the whole equation 1 minus sine square x minus sine square x is equal to sine x. Let's bring everything to one side, and it's going to give me 2 sine square x plus sine x minus 1 equal to 0. If you recall factoring from previous class, if you have 2x squared plus x minus 1 equal to 0, it is factorable. I'm just going to quickly show you. Well, maybe I shouldn't use x. It might confuse you. Let me just use t or something. This piece has nothing to do with the given problem. I'm just trying to show you that you can factor it. We're looking for two numbers. They multiply to give you negative 2, add up to give you 1. They're 2 and negative 1. We must divide them both with a 2t and 2t. Simplify, so my factors are t plus 1, 2t minus 1, and then we can plug each factor equal to 0. Again, the same thing I'm going to do over here. This is like my t. My t is actually equal to sine x in this case. So when I factor it, it turns out to be 2 sine x minus 1 and sine x plus 1 equal to 0. And I get sine x equals 1, sine x equals, this is 1/2, sine x is equal to negative 1. Sine x is 1/2, that's happening at pi over 6, 5 pi over 6, and sine x is negative 1 at negative pi over 2, which is 3 pi over 2. Okay, hold on. Sine x is negative 1 at 3 pi over 2. The y value is negative 1 at 3 pi over 2. Okay, cool. Next problem, we have number 14. Let me see if this page was all done. Yeah. Number 14, got to solve 4x squared plus 12x plus 3 equal to 0. Okay, so it's a quadratic equation. How do I solve this equation? Let's see. Is it factorable? Can I think of two numbers? They multiply to give me 12, add to give me 12. Nope. There's no two numbers like that, so not factorable. That means I have to use quadratic formula. My a is 4, b is 12, c is 3. Make sure the signs go with them. If there was a negative in front of 12, that would make your b negative 12. X equals negative b plus minus square root of b squared minus 4ac divided by 2 times a. Okay, so that's negative 12 plus minus square root of 96 divided by 8. We got to break that 96. It is 16 times 6 divided by 8. Negative 12 plus minus, I can pull out a 4. And now we can pull out 4 from the top, which becomes negative 3 plus minus square root of 6 divided by 2 as my final solution in the simplified form, because we don't want to leave any common factors between numerator and denominator. Number 17 B is what we're going to look at next. Number 17 part B. That is going to be 5x minus 2 absolute value equals 8. Absolute values are very strange behaving functions. They're piecewise functions. They behave differently in different domains. Okay, so whenever I say absolute value of a number is equal to 8, the number can actually lie at two different spots on the number line. The number 5x minus 2 can lie over here, or the 5x minus 2 can also lie over here. Both ways the absolute value would be equal to 8. So I'm going to say 5x minus 2 is equal to 8, or 5x minus 2 equals to negative 8. So 5x minus 2 equals 8 gives me 10, x equals 2. From here, I get 5x equals negative 8 plus 2 is negative 6. X equals negative 6 over 5. Okay, I also want to do number 16. I believe I did not copy it down here, but I want to do number 16 as well, part A, which is solve the inequality x squared minus 2x minus 3 less than equal to 0. How do we solve a quadratic inequality? Well, to solve a quadratic inequality, the first thing I need to factor the quadratic inequality. So I'm looking for two numbers. They multiply to give me negative 3. They add up to give me negative 2. They would be x minus 3 and x plus 1 would be my factors. Now my critical values are negative 1 and positive 3. Now I'm going to see if I plug a 0 in here, I get something negative. If I plug a 4, I get something positive. If I plug a negative 2, I still get something positive. So looking at my inequality, I wanted it to be less than or equal to 0 means I wanted it to be negative. I also wanted to equal 0. That means we are supposed to include the endpoints. So between negative 1 and 3. Okay. Next, we're looking for find the equation of line passing through negative 1 comma 3 and 2 comma negative 4. Okay, equation of line passing through these 2 points. Call this point x1, y1. Call this point x2, y2. First thing I'm going to do is go ahead and find the slope of these 2 points. Formula for slope is y2 minus y1 over x2 minus x1. Difference in y coordinates divided by difference in x coordinates. So I got negative 4 minus 3 divided by 2 minus negative 1, which is negative 7 over 3. That's my slope. Once you have the slope, we can use a point slope formula, which is y minus y1 is equal to m times x minus x1. Okay, so y minus y1, at this point, it's up to you. You can use any of those 2 points that are given, either the first point or the second point. It does not make a difference. At the end, your equation is going to be same regardless of the point you use. So y minus y1, I'm using the first point, x minus x1, that would actually become a plus 1 here. Now you can go ahead and distribute, simplify. It would come out to be y is equal to negative 7 over 3, x plus 2/3. And that's my equation of line passing through these 2 given points. We will actually be finding a lot of equation of lines. Remember this point slope form of the line. Okay. Next problem we have is number 20. Part A, we're looking for the domain of this function. Okay. So domain of this function, in the notes I talked about the domain restrictions. There's a few domain restrictions in algebra that you must have learned in college algebra. First one, denominator cannot equal 0 because that makes your function undefined. Radicand of an even root cannot be negative. If you have a square root, fourth root, sixth root, you cannot have a negative inside. Log of 0 or log of a negative number does not exist. These are the three domain restrictions you'll have to keep in mind. And let's go back to the problem we were looking at. Well, I do have a denominator. I also have a radical. So the denominator cannot equal 0. That means x squared plus x minus 2 cannot equal 0. The second restriction is because I have a square root, the radicand must be positive only. It cannot be negative. Usually it can be 0. It's okay to have the radicand equal to 0 because square root of 0 is 0. It is still a real number. But this case, because your radicand is in the denominator, you don't want it to equal 0. So we want it to be greater than 0. Let's go ahead and factor this now. Two numbers multiply to give you negative 2, add up to give you positive 1 are here. Let's go ahead and find my critical values are negative 2 and 1. In between, I have a negative, I have a positive here and positive here. So the domain is going to be, I want it to be positive, greater than 0, which is happening from negative infinity to negative 2. Should I include negative 2? No, because that will make your denominator 0. Okay, and same way we should not include 1 either. Your domain is negative infinity to negative 2 and 1 to infinity. Next problem is find the domain and range of, this is number 20, part B. To find the domain and range of these functions, well, f of x is equal to 7. The domain of this function, f of x equal to 7. What's the domain here? Domain in interval notation is all real numbers. The range is y such that y equal to 7. Because this function does not, it's not increasing or decreasing. It's a constant function. If you graph y equal to 7, f of x is the same thing as y. And that's how your graph is going to look like, okay? For part G, we have f5x minus 3 divided by 2x plus 1. What's the domain for this function? Domain for this function is going to be, let's see. Domain would be all real numbers other than 1/2. So it would be x. Other than my 1/2, I can use any of the x's here. I would have to graph the function. Let's see, 1 second. Okay, so I have to Alright, so domain is x such that x is not equal to, x can be any real number, so we can have any real number. X belongs to R such that x is not equal to negative 1/2. Because if x is equal to negative 1/2, then I have, I'm going to have, if x is equal to negative 1/2, then I would have the denominator as, sorry, I'm looking for decimals. Okay, and if x is equal to negative 1/2, I would have a 0 in the denominator, and that's not okay. Now for graphing, I know there is a horizontal asymptote, but your graph can cross the horizontal asymptote. It's not a domain restriction or the range restriction. It's not a discontinuity. Your graph can always cross the horizontal asymptote. It does not always do that, but sometimes it can. In this case, looks like it does not. So my range here would be y such that y belongs to real numbers, but y is not equal to 5/2. That would be my horizontal asymptote in this case. Okay. Find the difference quotient. That's number 21. That's what we're going to look at next. To find the difference quotient, make sure you know how to do this, because when we do derivatives, we would be talking about difference quotients again. F of x plus h minus f of x divided by h. That's called the difference quotient. My function f of x is 2x plus 3 in this case. Okay, let's go ahead and find out f of x plus h. All we have to do is we have to replace the x by x plus h, and that would be by f of x plus h. Just like if you want f of 3, you replace the x by 3. So this is 2 times x plus h plus 3. Let's go ahead and plug them into the difference quotient now. So it's f of x plus h minus f of x divided by h. F of x plus h is actually equal to 2 times x plus h plus 3 minus 2x plus 3. I put the parentheses because I would have to distribute the negative sign. So I have 2x plus 2h plus 3 minus 2x minus 3 divided by h. The 2x is cancelled, the 3 is cancelled. I'm left with 2h over h, which is equal to 2. So my difference quotient is 2 in this case. Okay, the next problem. Find the inverse of the function. So for this function, find the inverse. How do I find inverse of this function? Let's see. To find the inverse, there's basically 4 steps. You can do it in multiple ways. You can do it by graphing and reflecting the graph over the line y equals x, or 4 steps. The first step is replace f of x by y. Second step is switch between x and y. Third step is solve for y. Okay, so I need to solve this for y. I'm going to cross multiply. 5yx minus x is equal to y plus 2. All right, combine the terms with the y, and the other side can be x plus 2. I'm taking the x to the other side. If I pull out a y, I have 5x minus 1 equals x plus 2. Y turns out to be x plus 2 divided by 5x minus 1, which is my f inverse. So I can say f inverse of x is equal to x plus 2 over 5x minus 1. Okay, and that's the end of this problem. Now we're going to look at find the minimum value of x squared minus 2x plus 3. Okay, the minimum value of, how do we find the minimum value of a quadratic equation? Minimum value is the vertex. If your parabola opens up, then the minimum value is the vertex. If your parabola opens down, then your maximum value is the vertex. Okay, in this case, this parabola opens up because we have positive coefficient. The a is positive. So to find the vertex is the min in this case. And how do we find the vertex? X coordinate of the vertex is found by the formula negative b over 2a, which is negative 2 divided by 2 times 1, which is 2 divided by 2 is actually 1. So x coordinate of the vertex is going to be 1 in this case. And if I want to find out the y coordinate of the vertex, I plug the 1 back into the equation, and I would get a 2 back into this equation. Okay, so I can say the minimum value is y equals 2. It occurs at x equals 1. Okay, next problem. We have number 28. Number 30, we're going to decide. Again, these problems are from the pre-calculus review from the supplement, and I don't have pre-calculus from the supplement. I did not do all the problems, but I did cover some of them. There's a summary in the front that you should review. You should know all of the stuff in the beginning, first few pages on the summary. Decide if the given function is even or odd. Y equals x over x squared minus 1. Really quick, a function is even function if f of x is equal to f of negative x. A function is odd function if f of x is negative of f of x. And if neither of those are true, then the function is neither. Okay, so I'm only doing A and C for number 30. Let's go ahead and, so this is my f of x is x over x squared minus 1. What's f of negative x? Well, replace every single x by negative x. It turns out to be that, which is the opposite of what we started with. So it's opposite of the original function. That means we can say f of negative x is equal to negative of f of x, because this is the original function we started with. That means it's an odd function. Okay, it would have the origin symmetry. Now we have part C here. We're looking for if it's even or odd. Replace the x by negative x and see what happens. So my f of negative x is going to be negative x to the third plus 2 times negative x plus 1. And that turns out to be negative x cubed minus 2x plus 1, which is not the same, which is not as original function. It's not the opposite of original function. So that means it's neither. It's not even, not odd. It's a neither function. Okay. Here we have number 41. Find the domain and range of each of these. Okay, so how do we find domain and range of each of these functions? All right, let's go ahead and look. So I also want to do actually number 32. Let me make some space. We can do it at the end. Find the domain and range of each of these functions. So domain and range, domain for 1 over x. I know if you graph this function, this is a famous rational function. Looks like this. Domain is, I'm going to write in the interval notation. Domain is going to be negative infinity to 0. Union 0 to infinity. That's going to be my domain here, and the range is also going to be the same, negative infinity to 0 and 0 to infinity, because you have a horizontal asymptote at y equal to 0 and it does not touch that. G of x is equal to square root of x plus 2. Now for this one, we don't want to have a negative inside. We are okay with 0 inside. So my domain would be starting from negative 2 to infinity. Any of the numbers are okay. And the range would be, I apologize, it's not going to be a bracket. It's going to be a parentheses. 0 to, no, it's going to be a bracket. I was right. It's going to be a bracket because it does touch the, this is how the graph is going to be. It does touch the x-axis, which is y equal to 0. Right, the next problem, S of theta is sine theta. What's the domain and range of sine theta? The domain is negative infinity to infinity. There's no discontinuities. It goes on forever and forever. How about the range? What is the range for the sine theta? Okay, the range for the sine theta is negative 1 to positive 1. The sine theta always stays between negative 1 to positive 1. Okay, so negative 1 to positive 1. Let's see, the range would be including negative 1 to positive 1. Sine theta does not go beyond negative 1 to positive 1. Okay, let's see, the next problem we have is t of x is equal to natural log of x. What's the domain and range for natural log of x? If you recall the graph of natural log of x, it looks something like this. Also, the x cannot be negative, x cannot 0. If you recall, the log of negative number, log of 0 is not possible. So the domain is going to be, domain is 0 to infinity, not including the 0, and the range would be negative infinity to positive infinity. It covers all the y values. There's no restrictions on the y values. Number 42. Okay, there's a few pieces of problem number 42 that I need to look at. F of x is given to me. G of x is also given to me. I want to find out f of g of 2. Well, it's a composition of two functions, but there's an easier way of finding it. It is f of g of 2. I can first find g of 2 and then plug that in there. If I plug a 2 in here for x, that's 13. Now, what is f of 13? 13 take away 2, that would be 11. If you plug that into f of x function. G of f of negative 4, you can also write it as g of f of negative 4. Okay, what's f of negative 4? If I plug negative 4 for x in f of x, that's a negative 6. So I need to find g of negative 6. G of negative 6 would be negative 30 plus 3, which is negative 27. F of g of x, this is composition of the two functions. So all I have to do is I got to plug g of x inside the f of x function. So I need to find f of 5x plus 3, okay, because that's my g of x. Now what does f function do to something that goes in there? It subtracts a 2 from it. That's it. So it's new x. It's going to pick up the new x and subtract 2 from it, which is 5x plus 1. Okay, and that's it. I'm going to do one more example. It's problem number 32 on pre-calc review of the supplement. So we have sine theta is negative 1 over root 10 and cosine theta is less than 0. Find tangent theta. Okay, so there's multiple ways you can do this problem. There's several different techniques you learned in trigonometry. You can use identities, you can draw your triangle, you can use the unit circle. I'm going to go ahead and use the identities. I know sine squared theta plus cos squared theta is equal to 1. And I can say cos squared theta is 1 minus sine squared theta. So cos squared theta is 1 minus sine squared theta, which is 1 minus 1 over 10, which is 9 over 10. Cosine theta is plus minus 3 over root 10. But because I'm being told that cosine is negative, so go with negative 3 over root 10. Tangent theta is sine theta divided by cosine theta. You already know sine theta is negative 1 over root 10. Divide with the cos theta. It is going to leave me with 1/3, and that's the tangent theta. Okay, one last example I want to cover is for factoring. This is a common mistake I see students make. They always use guess and check for factoring, but please do not use guess and check. This is not in the pre-calculus notes in the supplement. It shouldn't say factors, it should just say factor. Okay, factor 2x squared plus 7x plus 3. I'm just picking an easy example that I made up quickly. I want to factor this equation. We don't have a GCF. The first thing you want to pull out, if there's a GCF, you want to pull it out. Looks like there's none in this case. So compare it to ax squared plus bx plus c. I call it the bottoms up method. I draw an x. A times c goes on the top, b goes on the bottom. A times c here is 2 times 3, which is 6. B is 7. I'm looking for two numbers. They multiply. So keep in mind they multiply to give me 6 and they add up to give me 7. They're 6 and 1. No worry about making any of these negative because they both work out fine. They multiply to positive 6. They add up to positive 7. Now, because your first number is 2x squared, you go ahead and divide both sides with 2x and 2x. This is why I call this method bottoms up. You can use any method you know of factoring, but I use this method called bottoms up. Okay, go ahead and simplify any fractions you can simplify. Looks like this one can be simplified and this one cannot be. Now it's time to do bottoms up. 2x plus 1 is my one factor and x plus 3 is my other factor. That's it. You cannot say x equals negative 3 and x equals negative 1/2 because you're not solving this equation. We were just factoring.